Morning, everyone. I'm Javier. I'm part of the front-end team of Global Fishing Watch. Three of us are here. Jose and Juan Carlos will be doing a quick demo after the slides, and will be support the QA. I wanted to, before we get started, a word of recognition to the contributors and maintainers of the Deck.gl ecosystem, and also to MapLibre maintainers and contributors, because the work you do enables like organizations as ours to do I think an important job and facilitate social impact that our organizations real life. So let's get started. We are part of Global Fishing Watch, that it's an international NGO that uses satellite technology, machine learning, and data visualization to build an accurate picture of human activity at sea. And we strongly believe that greater transparency can support the sustainability of our ocean. So our code, our tools, and are free and open to anyone. Last July, we deployed to production a full overhaul of our map architecture, consistent on switching all map-related code from MapLibre to Deck.gl. I'm going to go briefly on an overview of data sources and app user needs, so we can all make sense on some of the technical decisions that made along the way. We have a bunch of data sources feeding the map. We have GPS-like data streams from 400,000 vessels since year 2012, and have processed around 100 million positions. Our databases are huge. We have tens of terabytes of data. Is then processed by our machine learning models. We use this data to infer vessel behavior, to be able to identify fishing activity, vessel types, and other kinds of events like port visits, when two vessels meet in the ocean. And we also process satellite imagery for the entire globe every day to fill the gaps when vessels try to hide their activity. We have a range of users that are analysts, researchers, journalists, public officials, and their needs are highly varied. I'm going to go through some examples of use cases they might go into. They could need to analyze large-scale patterns of human activity at sea, such as where and when the most fishing occurs in an entire ocean over years or months. They could also need to create subsets of data to compare specific types of vessels or those from specific countries. They can style those subsets to better find insights on the data. Or they might need to drill down to specific vessels and analyze their tracks and events, such as they went to port or when they met another vessel on the sea, when there was fishing activity. We also allow them to create reports of activity for specific areas, like jurisdictional waters, national boundaries, protected areas. There was an example of a exploratory behavior of a user digging into some place and some moment to understand behavior. Well, no worries. We can see.
Maybe you can try exit full screen and it might work. It's not full screen. I don't know.
No.
Well, if you escape to the editor, then that worked yesterday for some reason. Now press play.
image with the certificate.
Right. Out there, yeah. No, in the top right of the video, little arrow,
The link to the seeing the video.
top right of the
top
black
right corner.
area. Yeah.
Okay, no, I
have no internet.
yeah, no worries. Later on in the demo, we will see better how the app works. Okay, so as we've seen, there is so much variation on the outputs the different users need from the map. Both geography and time are key components of the insight the app provides. And they need to be highly customizable and responsive to serve all user needs. And that's why we came up with a data format that would give us enough flexibility to address all these cases and 4Winds tiles format. I'll try to briefly explain 4Wind tiles so we have the full pictures of user needs and what we need to provide them in regards of amount of data and responsiveness of the interface. Since our users are interested in so many different temporal extents, we created this custom protobuffer format that serves temporal data disaggregated. It is optimized to have a smallish payload with associated temporal data. We can fetch the data on ranges of hours, days, months, or years. So users can explore and update the time frame they are interested on the interface without constant requests to the server. As we can see, in the same way, a global map doesn't show every street on zoom 0. We can show days data when users' time range spans multiple years that generate a huge payload from the backend. So this on-demand granularity makes payloads manageable and data easy to analyze. Also, an advantage of the format that is tiled, so geographically aware, is that the data is sent without any sense of the geometry it will be displayed on. So it allows us to choose different visualizations in an easy way. With the same tile format, we can display a heat map or cluster points on the map and even create non-geographic visualizations like the ones in the time bar or reports. And the app doesn't only need to render data in a canvas as a map. We also need to access data in other contexts, such as a list of vessel events, legends, aggregate data for the time bar or report graphs. And also, we need to read the data loaded to suggest better visualizations in certain conditions, like vessel positions when feasible, depending on data density on the viewport in that moment.
Sorry, was it bivariate color scale in the heat map?
Sorry?
Is this a bivariate color scale?
Yeah. Yeah. So we can decide if we want to display colors for. So this is a fishing activity, and this is the different colors depend on a category for the vessels. Maybe it's a vessel type or it's a flag that they are from different countries. And in there we are seeing with the color of the vessel that has been more hours in that specific grid cell. But we can also display it so here we can see the overlap of both. So probably here there's no overlap. There's overlap of both categories. And we can choose between the two visualizations.
Javier, why use tiles and not database?
Why use tiles and not database?
Yeah. Why use a tile format and not just query the
if you want to.
Yeah, technically we use both. It's a huge database that generates tiles on demand. So the database it has some things pre-computed, like what cell and tile its point falls into. So you can search the tiles quickly. But it is a database.
All right. Good. So let's dive deeper into the reasons behind the migration, why we did it, and some examples of how it improves some of the data render flows and code-based maintainability and scalability. But before, some history of the app, because this is a project that spans from 15, probably 10 years now, more or less. So this is the version 1, Google Maps base map and Deck.gl. Version 2, we moved Deck.gl to Pixie.js. That's a 2D canvas game engine handling the heat map layer. We then migrated to Mapbox, and when it get closed source, we went to MapLibre. That was 4 years ago. To support the integration of the 4Winds data source, we have control over datasets merging, fetching, and parsing. We've been maintaining first a Mapbox fork and after a MapLibre one. Even though it worked quite well, the solutions felt somehow hacky and ad hoc. Too much context was needed to maintain and update the code, and we were out of control in some steps of the pipeline. So we started playing with Deck to understand how it would serve our use cases and if it could help us to bypass some limitations or pains we were facing. Also, another reason had to do with increased ambition in the organization. So our plan is by 2030, map all human activity at sea. And exponential growth in data sources requires us to have total control over every step, from data fetching and loading to filtering and visualizing. That's a structure of a real layered custom layer that layers. And from the beginning, it was clear that Deck modularity and composability would be beneficial on the maintainability side, allowing us to simplify and encapsulate many of the map-related code. We are not going to go through implementation details during the presentation, but we've left some GitHubs links to relevant files and folders in some of the slides, and well, free to ask questions in the QA in case you want. Before going to a couple of custom layers breakdown that let me draw your attention on how paramount is the interaction between the map and the time bar in order to allow users to explore the data and gain insights of behaviors of activity in their areas of interest. Well, let's check some examples. This is from the vessel track. That was the one before. So on the MapLibre implementation, data received from the server needed to be parsed, transformed, and filtered on the CPU in order to be handled to the library to do the rendering. With Deck, on the other hand, we are able to save a lot of resources by handling the binary data directly to the layer and leveraging the capability to inject shader code on the rendering pipeline to do the filtering. This has led to an increased capability to display more tracks, unleashing new use cases, allowing our users to work with more vessels at a time, and even with entire fleets. I think I'm gonna same problem I just did connect to the Wi-Fi.
Oh, click on that. It's good. There.
Okay, great. Let me. Sorry. This. Oh.
It's a miracle.
Need to go to what happened. A new tab here. You go to google.com or something. Okay. Let's try it.
Google.
Waiting for the.
Yeah, you can keep going.
Yeah. Yeah. I mean, we are going to do the demo and from.
You want to switch to MapLibre?
No. Sorry.
Mine is connected and Slice had.
Speak Spanish.
Yeah.
International person. You are a very international person. ¿Cómo es Spanish?
How? More of a how.
How?
What is it?
Not a Mac user.
That's the plug, I think.
For the entire room.
I think because when maybe here on section.
Yeah.
Probably. It looks all right, actually.
Sorry. So having full control of the rendering pipeline allow us to achieve performance gains that effectively unlock features for users. Here we can see a fleet of Chinese squid fishing vessels fishing near Galapagos protected area waters. Galapagos park rangers can now analyze and control a higher amount of vessels on their flowing coast. Yeah, we can see here the. You can see here the time bar interaction driving the update of the 4 winds heat map. Regarding the 4 winds layer implementation in the MapLibre fork, after composing the URL with all the needed attributes to hand to our API, we received the tile and had to pre-calculate all the possible values in each frame of the selected time range. That was needed so the library could update the layer in response to user interactions on the time bar through Mapbox style expressions. On the deck implementation, we are still doing some heavy calculations on the CPU, although much more lighter than before. And there's an open door for improvements by letting the GPU handle the aggregation. That's something that we want to explore further. There were some unexpected improvements that we had the chance to gain along the way. While we were refactoring all the code base, we had the chance to do it. These were not planned, but the flexibility and control Deck provided us allowed us to implement them in an easy and robust way. Some of them are long-term requests from our users, and others have allowed them to better understand the data behind the map. regarding payloads. Here we can see a layer with 3 vessel types. We fetch each source separately, but we group all the values. In each cell, we need to know the values of each sublayer, paint the cell with the color of the most active one. But we need all sublayer values to drive the interaction, also the time bar graph. Previously, every time we changed any sublayer visibility, we had to request and move all the data from the server again. But now by splitting the requests in each sublayer, we are able to take advantage of the browser cache to save bandwidth and server resources. We got great feedback from marine protected area managers of Ascension Island that have reported an increased perceived performance with their low bandwidth connections. Also, this was something that was talked about yesterday. We are using the tile layer to fetch data and combine all the tiles on viewport load. And this allows us to choose between visualizing individual points or clusters, depending on data density. The same on the heat map or positions layer. So we can switch between a heat map or individual boats positions, depending on the number of points that are in the viewport. Also, regarding dynamic ramps, the ease of access to the loaded data also allow us to dynamically generate the color scales, always showing the users the best possible representation of the data, regardless of viewport or time range. We are currently doing this on the CPU, but we would like to explore also how to handle that calculation to the GPU. Before we were like best guessing and kind of dividing by when moving, zooming in. But now we have like the full picture with all the data of the viewport and can hear that we gain more insights of the data that we are seeing. Also, we have user control resolution. So by simply changing tile layers zoom offset, we allow users to see the data in different resolutions depending on their needs or bandwidth. A fair amount of our users are based on locations with low bandwidth connections. So having the ability to explore the map in low resolution until they find the spot or time frame they would like to dig deeper into could save a lot of data fetching. And yeah, we come from a state that we were facing the limitations of the previous implementation in some use cases, like amount of vessel tracks that could be displayed and animated at the same time, or poor experiences on low bandwidth connections. We are quite confident this app overhaul puts us in a very good position to face the challengers in the years ahead. The doors open to easily work with binary data or leverage computation and filter in the GPU would allow us to be prepared to serve our users as more vessels and more satellite imagery gets into the tool. That's all. Well, you're hiring. Anyone is looking for a job. That's all from the slides side, like this overview of the tool. And we are gonna do a quick demo of a user flow that can be quite. Yeah, Carlos, please. Sorry for the hiccups.
I'm gonna mirror my screen so I don't break my neck looking at it constantly. So yeah, let's do a quick tour of how the tool works. And if you have any question, we can move around or talk about what each layer does or how. Whatever. The default view is usually just the last 3 months of data, something like that. But here we are loading like 12 years now and growing. This is a parenthesis effort. Like Javi said, this is already tagged data. So we receive positions of where vessels are. And with machine learning, we, depending on the patterns, we determine if they are fishing or not. So this is like the main data set that we provide, open both in API or bulk download, and also the tool is completely open without login requirements or anything to anyone. So here we are seeing, like I said, 12 years of data for the entire ocean. And from here, users can decide of what are their time rates of interest and area of interest and start exploring from there. Let's say we want to see just 2023 and we start seeing monthly data instead of yearly data like we had before, but still for the entire ocean. And we can go to an area of interest or filter a bit more, like we can move months or filter to a month of interest, like June, for example. And let's explore the example of the squid fishing vessels that he mentioned. There is a huge float of Chinese vessels that every year goes near Galapagos to fish squids. They have like stadium-sized lights that they point to the ocean to attract squids in the middle of the night, and the squids go to the surface thinking it's already daytime. They catch them. It's like hundreds of vessels that move together, and they create a huge problem for Ecuador and for like the protected areas that are in the area. So if we filter or go first near Galapagos, for example, and if we filter the activity by vessels under this flag and that are tagged as squid diggers, the algorithms not only know if the vessel is fishing, but depending on the movement pattern, also infer the type of fish they may be catching. It's quite different between different fishing gears. So yeah, here we have this blob of vessels that we can see how they move and where they go. And we put here the areas, it's the Equatorian exclusive economic zone around Galapagos. You can see how sometimes they get close to territorial waters, sometimes even inside. And that's why the Galapagos Park Rangers are constantly using the Mach to monitor their waters. They don't have a system with their own satellites or with their own, they don't have a huge fleet of helicopters like or developed countries usually have. So they use this tool for that. From here, we can explore, try to see what vessels are operating here. We can say we are interested in around this area. If the data is not super dense and we don't have a lot of positions, we can switch to this mode that is position by position mode, basically, where instead of grouping all the positions into a heat map, we show directly net.
It's always slower when you're not on localhost.
Yeah. Well, we can basically just see each vessel position instead of the heat map of the group, but we can go back.
The name of each vessel and,
Yeah.
and their movements.
Oh,
And
but now nothing goes. Fresh. It's a demo effect. What else we can do? Yeah, just maybe interested in what vessels are driving that activity, and they can go to that position mode, or in the cell mode, they can click on any cell and see what are the most active vessels in that area, and they can add them to their workspace and see their tracks. We also analyze the tracks not only for fishing activity, but things like loitering. When they go slow, it's forbidden in some areas to go too slow to catch more fish, things like that. So it's important to know when they are loitering. Encounters is when they meet other vessels at sea. It could be for offloading catch to like a freezer vessel, things like that. Or when they visit ports and what ports they visit and everything. So we have those events on top of the tracks as well. And like temporal component, as he said, is very important to understand how the movement patterns and the behavior. But also, users may need to do that for all the vessels here, and they don't know if this is 20 vessels or 200. So we allow them to do reports. It could be on areas that are already present on the map, like an economic zone, or they can draw their own areas. Say we want to see all these vessels to see if they are the vessels we know and have permits to be there, or maybe there are new ones. You have to create the, say I call it squid diggers. So all right, yeah, I have my area here. This is the code of this area. Yeah, and from here I can create I can download the data. Every time anything you are seeing, you can download in CSV or GeoJSONs or GeoTIFFs.
This report created on the client or on the server?
This report has two parts: one that is created on the client and one that is created on the here. It doesn't need to load anything. I'm not sure what's doing. It shouldn't load anything. We already have the data on the client, and since it has the type aggregated, what we do is filter the cells by the polygon on the front end and create a only for the area you're looking. So I'm gonna refresh to see if that works. Yep. So yeah, this is the time series. This is on the front end for every sublayer you have. You may be comparing these vessels with other vessels. For example, let's try it even if internet doesn't want to.
So the heat map, the time series, and the time bar graph are all created from the same 4Wind style.
Here I turn on another source of data that is country data. Instead of just receiving GPS like positions from the vessels, some countries also send us their data. In exchange for having access to the tool, well, every country has access to the tool because every person has access to the tool, but we collaborate more closely with some countries, and they send us their data from their terrestrial stations as well, not just satellites. And that's what is called BMS. As it appears there, we have 10 countries now in collaboration, and in here it's shown as that orange. So if we open now the report, yeah, we see both in this case. The Chinese squid diggers and all the activity from BMS that's not filterable for any flag or any. And if you want to see all the vessels, then we need to go to the server for that.
Sorry, do you also see vessels which have their transponders off from satellite?
Yeah. Instead of waiting for this to load, we can go to see that. you want.
Because I think like much of illegal fishing happens.
Well, it's surprising to see that sometimes it happens with their GPS turned on. We've had instances where huge fleets that are from powerful countries go to less powerful, to the waters of less powerful there. Like there was a big instance where a paper done by the organization changed behavior of the Chinese fleet. It was in North Korea. We found that thousands of vessels were going every day and destroying the waters there, basically. It was creating a huge problem because the smaller, more artisanal fleet that North Korea has and that it's food for the people there, a lot of fishermen were dying because they were moving
farther from the coast.
To avoid the areas where the Chinese vessels were fishing because they were too small and the Chinese vessels were like really frightening. So they moved too far and they went ashore and they appear sometimes in the coast of Japan. Like there are instances where, and those vessels, some of them had the GPS, the IES turned on, and some didn't. And the way we found out where
This particular example, I mean, like, it's not in the ECIT zone, it's not in the protected area. Is that considered illegal fishing?
no, this is legal. It's just a problem how unregulated it is. In terms of fishing, we always talk about IEU fishing. It's illegal, unreported, or regulated or unreported fishing. And there are different problems. This is not a legal problem per se, although Ecuador tries to get into agreements with China to stop or give license for some hundreds of vessels, but not thousands, and that's not work, let's say. But the example to when they turn off their IS, what we do is night lights satellite night lights dataset from NASA, the beers, or like in here, these are squid diggers and they use these huge lights. It's really easy to see them. It's only 1 point per day because the satellite only passes a couple of times over that area. We only see them in the middle of the night. But these ones, it's almost the same information that we have from what they saw to what we see in satellites because they're really easy to see. But other vessels are also possible to see with the NILETS dataset. And also we have a synthetic aperture radar dataset where you can see in this area where we have data is much closer to the coast because these satellites, when they are going over high seas, they basically stop taking pictures to recharge. But it's also really interesting to see areas where, so the polygon you're seeing is where the satellite has passed in these days, where we have like coverage of satellite. And you can see some areas of high traffic, even from this dataset that only takes 1 or 2 images. Since the satellites are from the European Space Agency, so Europe is a bit more covered by them. But it's really interesting to combine, only for what you said, when they don't have a transponder, they're usually doing something they don't want us to see.
And on the data pipeline, we try to match some of these occurrences with GPS-like data, so we can identify the boats.
Yeah, you can click on the cells of these datasets as well, and if we match the tracks of other vessels with them, you can see also here.
They start a journey with transporters on and at one point switch it off.
Yeah.
Could see the beginning as well.
It could be that, or it could be that in a big fleet, just a couple of vessels have the transponders on, and then you can infer what flags or types of gear are fishing if they move together. I'm not sure if I missed something in the presentation. Any other questions? Or
You're using Google Maps, right?
Google
Because they have nicer
Google Maps for
depth.
the satellite-based map. Well, Google is one of the founders of the
Oh, okay.
organization.
Do they also have a better like ocean depth map?
We have our custom base map.
It's custom. Oh.
Yeah, this is a custom base map. It's just a bitmap layer and a solid polygon layer. This bitmap layer is from NASA. It's like a high def bathymetry. And then we have the satellite. And we also have another bathymetry that is gridded in the same way that we grid the data sets. Because sometimes it's important to know the depth of when.
So you're not using MapLibre or Google Maps at all now? So
No, it's only Deck.gl.
Since we don't have a custom, since we have a custom, we didn't so the need of dependency.
There's like a raster base map.
Yeah. In this case, it's a raster over here and
Just like
further 2 layers.
you've not added a globe or anything like that?
No, we have the mini map that we call. And whenever someone asks for a globe, we say that.
I'm gonna use that.
Globe view is controversial because you lose a lot of data. You're losing half of the data, and sometimes it's useful to have the full picture to understand patterns.
We always ask users that if you want to see the full world, always because you're comparing 2 areas of the world. What if they are not in the same half? Like those, I think, are really nice for other use cases for analysis of patterns.
What about the projection? Here you're all with Web Mercator.
It's Web Mercator, and
I'm sure some people are pressing to change the projection.
yeah, but we're doing, I think, something that solved a bit or increased the request for changing the projections is that we are using our grid equal area for the data. So it's tiled, but we don't have the same amount of cells in its tile. We have the cells have the same area. And that helps because they are really comparable.
So just like a stretch.
Yeah, if you go in latitude north or south, you see that they're not.
Yeah, but I mean, that's good for analysis, but visual analysis kind of like, I mean, it produces the problems, right? Because, you know, like everything north looks way bigger or looks more overfishing. Yeah. So that's why I'm thinking like, if you could, would you actually go to to other projections?
Yeah, for all the visualizations we do for papers, instead like static ones, we use other visualizations, of course. So
different projections will be a big deal for you guys.
We will change it day one. For sure.
In theory, if you switch that to globe view, then all the potential points that should work.
The problem with the globe view is that of some analysts actually need like comparing 2 oceans. But then, for example, with that example of if you filter here by a flag, let's say the Spanish vessel, so another big fleet, you want to see where in the world they fish. The globe doesn't serve you that purpose.
Right, but you know, another projection, just
another projection will show a better picture of that.
But with Web Mercator, you can't show data for both.
But there's not much fishing there, so users don't really request it. We have other datasets that are support, like we have environmental datasets like temperature, salinity. We can see here the list. We have chlorophyll concentration, or nitrate concentration, oxygen concentration, pH, and those datasets will be interesting to see closer to the poles. But usually, or users are interested in fishing, so it's not a lot.
Are any of these data sets open? Do you make this?
All of them are open, available for bulk download or API usage.
The public API that is open is the same one that serves the map.
But that's a custom, custom vector tiles format.
We have, for tiles, we have 3 formats in the API. We only use the custom PVF one in the map, but we also have MBTs.
Without the temporal support.
With temporal or without, you can request all the temporal values for your time range, or you can request just one value of the aggregation or average value in that time range. And you can request a PNG as well.
Can you just do a flat file download?
File?
Yeah, just get the entire table.
We have one tool called the data download portal, where you can download the whole world, each day of data or each year of data. And it's a CSV.
You're building some cool stuff. Is anything source or
Everything.
Yeah, everything is open source. Yeah.
Feel like some of these things, like your tile format, or that could be additions to the ecosystem.
We talk with some organizations about making that format into standard-like thing or something that can be used by others. So far, there are other organizations using the format, but because they're interested in our datasets, so they use the datasets either as an MBT or as a PVF. But we don't have yet use cases of. I mean, we know use cases, but we haven't collaborated with because it's a set of decisions in an infrastructure. It's not just a tile format. You need to have to make it quick, to make it fast. You need to have the database need to be pre-processed to know the cell where each point goes and everything. But it works. We are currently in query as the backend, but switching to another service called ClickHouse. And it works on other SQL.
Can you consider any other data format with these tiles?
Yeah, we tried Parquet.
Yeah, Arrow, yeah.
Which it's perfectly fine, and our format actually is almost a replica of a Parquet by chance. But the problem is that it's just a bit bigger. So since we already have the optimized version,
Roughly how much bigger?
like 30% in the. It was like 30% when we tried it, and for the dataset we tried. And for example, environmental datasets are a bigger payload because the full ocean is covered. In the other ones, sometimes you have sparse data and you have gaps that make the data smaller.
Because we do not send coordinates since it's tiled and
It's like a full tile.
geographically aware.
Tile only has IDs, so it tells you in the third cell we have this data.
So that exists already on. It's just that you've come up with your own global identifier called system.
Yeah.
There's already a few supported like H3, quad beans. We use it a lot in Carto, but they don't have like equal area. So I know that they don't fit your demand.
For equal area and for tile support.
H3 kind of does, but it doesn't.
I mean, this is also probably not exact.
But still, I mean, like it sounds like a spatio-temporal. I mean, like temporal support on grid layers is what you guys have implemented here, and that I don't think exists on Deck.gl on the formats. We are hearing quite a bit of demand for this type of things.
Yeah.
And
right now the implementation is super tightly coupled with endpoints with edge from. So we have in the mono repo libraries with deck layers and deck loaders. So maybe the loaders could be published and useful right away.
It's a very simple loader that it just knows when it needs to jump from a cell to another and stores the values as temporal values, and it's very simple.
But the layers are tightly coupled to our use case and our endpoints. So
I don't see why it cannot be generalized. This is very
yeah. They
anybody doing kind of like meteorological kind of like visualizations will want to have this type of visualizations.
We thought of doing it that way, but we said, okay, let's iterate. Let's before do it for our own and do not be too smart from the beginning.
The environmental datasets right now are COG files. We send in our custom PBF, but the source is a COG file. And we talked with Google Earth Engine before because we were using directly Earth Engine as the source of the data and as
Sorry.
with them and it would be great if they could serve files of their data directly in this or other form.